Teams Madras Chapter. PIT, EDC, IAC, IEEE, IETE, ISF welcomes you all of the Phase 3 AICT sponsor short-term training program on machine vision for entrepreneurs launching a startup with low seed fund. It is a great pleasure for me to introduce our speaker, Dr. M. Premkumar, professor in EC department at Panimalar Institute of Technology. He has graduated with the BE in Electronics and Communication Engineering from KLN College of Engineering, affiliated to Madurai Kamaraj University, Madurai in 2001. He obtained his ME in Communication System from the MEFCO Chalang Engineering College, affiliated to Anna University, Chennai in 2004. He completed his PhD in the field of wireless communication from Research Center, Tyagarajar College of Engineering, Madurai, Tamil Nadu, Anna University, Chennai in 2013. He has more than 17 years of teaching and research experience in wireless communications, wireless networks, signal processing, and its allied areas. He has published several research papers in international journals, international conferences, indexed in Scopus and SCI. He is reviewer in international journals, has been awarded with the Best Paper Award in National Teacher Congress 2019. He has been coordinated for AICT, STTP, and worked on research funded project. I welcome you, sir. Prem sir.
Sir, you can unmute yourself. Your audio is muted.
So now I hand over the session to Dr. Premkumar sir.
So thank you, ma'am. Thank you for the introduction, ma'am.
Thank you, sir.
Am I audible now, ma'am?
Yes, sir, you are audible.
Okay, thank you, sir. Thank you, sir. Thank you very much. So good afternoon, one and all. So I extend my the thanks to the opportunity provided by the management, heads of the department, and faculty members for giving an opportunity to talk in this AICT sponsored STTP on machine vision for relating to the topic of wireless system startups. Okay, so once again, so the topic for today's presentation in the afternoon session is machine vision for wireless system startups. So I'll just share my slide. Okay, ma'am, is my screen in presentation mode, ma'am?
Yes, sir. Yes, sir.
Okay, ma'am. Thank you, ma'am. I'll continue. Okay, so the topic for this session is actually machine vision for wireless system based startups actually. So as you know, machine vision is nothing but we might have seen in the morning introduction section given by the speaker. So machine vision is nothing but analyzing systems in whatever perspective, whatever research issues which we need to solve by using cameras or smart cameras or machine vision and thermal imaging cameras and so on. So anything related to cameras will come under machine vision. Now what I'll do is I'll just add on how to go in for startups for machine vision based systems considering the wireless. Okay, so I'll go into the presentation. So the objectives of this particular session is that machine vision wireless system startups. So to help researchers in academia, industrial sector, so contributing to machine vision for wireless and its startup possibilities. So as you know, startup is nothing but it is a small scale investment. A startup is nothing but a small scale investment which a particular entrepreneur, probably a student or a faculty member, decides to market any particular idea or try to brings up some idea for some commercial viability. Okay, so that is what we mean by a startup. So startup is actually either owned by a single entrepreneur, or you can have multiple entrepreneurs either from the student level or from the faculty level. And so startups can be done in any particular area in the field of embedded or imaging or whatever it is. Now considering the fact machine vision, as we go in for more digitization in nowadays, so machine vision, and I'll just add on how to go in for machine vision with wireless concepts. Okay, so actually machine vision with the wireless system startups, actually it is a low cost investment. It is a very low cost investment. That is, we are going to work on the back end side of any particular electronic gadget or any particular electronic equipment. That is what you mean by the first objective which I have stated here. So then analyze wireless system startups for machine vision, relating to machine vision, its pros and cons actually. So then contribution towards research and development, catering some issues, catering some problem statements relating to wireless systems and along with machine vision. So ultimately, it should end up in a particular product development for a particular startup started by an entrepreneur. Or what you can do is you can just go in for some consultation like startups. So that is what you mean by the objectives which are stated for machine vision wireless system startups. So the presentation outline is that so the machine vision wireless system, you have the layout. I've given the layout and section. So machine vision wireless system architecture. So what are the possible wireless system models? Can we have? Can we collaborate machine vision? And that is it is just converging of or concatenation of machine vision and wireless system concepts, so that we'll be having what to say a low cost startup based arrangement. Okay, then I'll let you know what are all the startup schemes in the central government and state government sectors. Then what are the pros and cons for machine vision wireless system startups. Okay. Okay. So before going into the original topic, so we'll go with some basic terminologies relating to startup, entrepreneurs, incubator, incubation cell, and so on. Okay. So, for example, if any student or any researcher or any faculty member, if he has some idea, if any student or a faculty member has some idea, and if he wants to make that one a particular product, so what you can do is so you can just approach any particular organization, in the form of an incubator or an incubation cell. So an incubator or an incubation cell is nothing but it is most probably a non-profit oriented organization, or it might be a profit oriented organization where it nurtures or helps any budding entrepreneur to have a startup to grow, so that his particular idea can be marketed for commercial viability. So, as you know, the startup is nothing but it is a company founded by one or more entrepreneurs to ultimately develop a particular prototype or a product or service, and ultimately market into the market for a commercial profit or something like that. That is what you mean by a startup. So a startup can be founded by a particular single entrepreneur, or you can have multiple entrepreneurs. That is what you mean by a startup. So, startup is a venture. It is initiated by its founders with an idea. As I said earlier, it is an idea or it is a problem with a particular potential. So, it has significant business opportunity to its impact. And startup, it can be either a temporary business model, or depending upon the progress, it can be a temporary business model. So, it can be a temporary business model. So most of the startups they are mostly temporary, because considering the fact it needs investment, it needs funding, you need to have some angel investors, some wealthy investors, you need to have some angel investors, wealthy investors, so that some backup needs to be done. So then only a startup can be transformed into a success, or a temporary business model can be converted into a permanent business model. Okay. So so, so most probably in the sense, depending upon the takeoff, a startup is considered to be a temporary business model. So as you know, incubators, which I have said earlier, so incubators are nothing but B schools. So there is a business schools which are most probably either like an NGO type or a non-profit organization, where they provide space, where they provide some sort of an infrastructure, so that they can develop the product, and with probably seed funding. There are many incubators available in different colleges, in different what to say in different organizations, whether it might be an NGO, or it may be central government or state government funded organization. So many incubators are there. So all you need to do is, if you have a particular idea, whether a faculty member or a student, if you have a particular idea, so what you can do is you can become an entrepreneur, and to make yourself to become a successful startup model. So you can approach any of these incubators, in where nowadays various engineering institutions are having incubators, incubation cell. So you can approach them, so you can convey your idea, so you can where they will provide proper space and other arrangements, so that it'll be a profit oriented one for the entrepreneur to start to go in for a startup, or it can also be a profit for the incubator or the incubation cell, which is run by a college, or which is run by any NGO or any central government or state funded organizations. So that is what you can say. Then there are specific business incubators, and they differ in research and technology parks. So business incubators, mostly they are non-profit oriented, and also profit oriented for incubators in the sense to a certain extent. Okay, so that is, they can provide what to say, free electricity to the startups, or they can provide free infrastructure. So some sort of mutual agreement between MOU, mutual agreement between the startup founder, probably an entrepreneur, which can be either a student or a faculty member, and then you can develop into a good what to say a good permanent startup model. So because most of the startup models because most of the startup models are what to say fail, because the reason is that they fail to take off because of a lack of funding or other facts. So that is what the main important thing. So, and in addition to that, considering the factors, market consideration, so the growth of the startup depends upon the market consideration, and also the idea which the entrepreneur which he plans to implement. Now, as I said earlier, I will be concentrating much more on how to develop startups, low cost startups, incorporating machine vision and wireless system concepts, so that any student or a faculty member or a researcher can start a startup with a very good idea and a low cost arrangement. Okay, and there are also angel investors. So angel investors, as you know, they are all wealthy investors. So wealthy investors, in the sense, they are mostly non-profit oriented, any NGOs, or what to say, or any organizations in any engineering college. So where they'll provide all these extra facilities to the startup founder, and so that it can be a joint venture between the incubator or the incubation cell and the owner of the startup. Okay. So this way commercialization can be done for both the institutions, and also you can have development for a particular startup, which is the objective of the particular concept of digital India. So seed funding is not at all an issue, considering the fact. So if you approach any incubation cell or any incubator, and if there are proper directions from an angel investor, something like that, or with or without an angel investors, you can go in for a startup. So starting a startup is not that much difficult. So we don't need to think of big bank loans or something like that. So there are various provisions in the website startupindia.gov.in. Even women and entrepreneurs are encouraged. They are provided with a 20,000 per month for women entrepreneurs throughout the year, during the first year of the starting. So I have given all these information in the last half of the slide. Okay, so last half of my presentation, probably this will be helpful to the participants here. Okay, so going further, so, as I said earlier, so my presentation view is nothing but concatenation of machine vision and wireless system startups. So, a machine vision startup or a startup is a company or a project which is undertaken by an entrepreneur. So, ultimately, to develop a scalable economic model. So, a scalable economic model in the sense, so it should be having proper viability in terms of theoretical perspective, and viability and validation in terms of practical perspective. So any idea you can easily propose in terms of theory through some mathematics or through some concepts, and you can later validate it by a practical setup. So as a machine vision wireless system startup, what I mean is that, so you can take on some particular startup idea with respect to wireless domain at the back end. So I'll let you know what is back end, what is front end as we progress through this presentation slide. So uh, so you can go in for validation. You can go in for a validation in case if you go in for fabrication in the RF section, front end, and validation at the back end section using the baseband system. So I'll let you know that one as we progress. Then machine vision based startups refers to a new business model that intend to grow large beyond the solo founder. Either you can have a solo founder or you can have multiple. And further, machine vision allied startups face high uncertainty. So high uncertainty in the sense because the type of investment, the amount of cost incurred in procuring the smart cameras, the thermal cameras, and for or whatever might be for required for processing. So because you need to capture the image or the video signal, or you have to break up the video signal into frames, and then you have to process it, and you have to go in for a proper idea for before giving a good solution. So there are high rates of failure in not only in machine vision based startups, in other startups also in either in the embedded case, or if you have RF based startups for any insertion loss or any what to say, so any isolation loss testing or something like that for any particular component. But the fact is, majority of them go into failure. The reason, the fact they lack direction. So direction in terms of investment. So investment, it depends upon the entrepreneur not to go in for a large scale, not to go in for a large scale investment, but with the idea of minimum procurement of components in case if they go in for a hardware, or minimum procurement of components in terms of or the softwares which they are going to process. Okay. So ultimately, for a particular startup, you need to have the right direction in which you need to solve a particular problem. That is what you mean by that. Okay. Okay. So machine vision layout section for the startup is nothing but, as probably in the morning session itself, the speaker might have introduced. Okay. So machine vision integrates image processing. So it integrates robotics and automation, optical concepts. So whatever might be the application task which you are going to take on, so you need to capture the image. So to capturing the image, you need to have very good cameras. Depending on the upon the application, you can have night vision cameras, you can have thermal imaging cameras, or whatever might be it. Then ultimately, image pre-processing, region of interest, image segmentation, feature extraction, and decision making. So obviously, all these concepts are evolved with respect to processing of images or a video signal. As you know, image is a 2D signal, and video signal is a three-dimensional signal. So I'll just combine the concepts of machine vision along with, and I'll take it to wireless, so that ultimately with low seed fund, with low cost, you can go in for a startup with very good ideas, and you can make profit for the startup and also for the incubation cell, or whatever might be the MOU which we are going to sign in if you approach a business incubator or an incubation cell. Okay. Okay. So this is the basic machine vision system model for a startup. So you need the proper lighting. Okay. So you need to have cameras. So cameras, as I've told earlier, whatever might be the cameras you can have, a smartphone, Android camera, mobile phone, and so whatever might be the thermal imaging cameras, or whatever might be the cameras, you can night vision cameras, or whatever you can have. So you have to capture the video signal or the audio signal, and then you have to transform that one into a, a digital one. So analog to digital conversion. So analog to digital conversion, as you know, you have sampling, quantization, and encoding. So you have to convert the analog signal into a digital signal through sampling, through a sampler. Then you have to quantize, rounding off procedure. You have all these stuff you have need to have here. So if it is going to be a video signal, you need to process frame by frames. You need to process frame by frames, and this the processing segment. So you can have different types of processor. You can have DSP processor where you can have billions of instructions per second. So DSP processor, in the sense, you have analog devices processor, you have Texas Instruments processor. Okay, so you need to have separate, as you know, all these analog devices and Texas Instruments processor, they have their own software, Visual DSP plus plus. You can have Code Composer Studio for processing. Then you can do whatever might be the processing, And in case if you are doing some automation, you need to have a robot control or something like that, depending upon the application. So this is a general setup whereby you'll be having a common machine vision system model. So either you can capture an image through the camera and you can do processing after analog to digital conversion, or either you can have a one dimensional signal straight away here and you can have AD conversion and you can have all these setup. Okay. So to introduce so the types of vision systems, so machine vision systems. So this is a well-known slide. You can have smart cameras, you can have PC-based systems, and you can have vision appliances. So smart cameras, as you know, smart cameras, as you know, they have processing, image capture, and everything will be done in the cameras itself. There is no other external circuitry required for further processing. So this is highly cost effective compared to PC based system. So you have inbuilt input and outputs. So various arrangements are there. Then PC based systems. So PC based systems, you have to capture an image, you have to process them, you have to capture into frames depending upon the video signal, and then you have various input and output models as similar to the previous diagram which you have seen here. Then you have separate vision appliances, specific vision appliances. So probably I will not be focusing much into the machine vision domains. I'll be going into the wireless system based concepts, so that the process of starting a startup with low cost. So because these sort of arrangements are highly cost effective. So whatever might be the case are cost effective. So as the object of this particular STTP is with low seed fund, I would just divulge into the backend wireless systems whereby you can create some algorithms. You can create some algorithms to analyze some metrics for any particular signal, one dimensional or a two dimensional image signal, whatever might be the case. And then you can go in for a low cost solution based startups. That is what I would like to stress on. Okay. So moving on further. Um, moving on further. Ma'am, am I audible, ma'am? Is my voice audible?
Yes, sir, it's audible, sir.
Thank you, ma'am. Thank you, ma'am. Ma'am, please let me know in case if any discontinuity, because
Sure.
my
Okay,
signal is getting disturbed, ma'am. Sorry to tell that.
okay, sir.
Okay.
Okay, sir.
Thank you, ma'am. So this mm, so as I've told earlier, I will just combine machine vision and wireless system concepts. So if you take any wireless system, so you'll be having two sections majorly. One is the RF section, the other one is the baseband section. As we all know, as most of the electronics and communications engineers or whatever might be the discipline of study. So the prime components will be the antenna, the low noise amplifier, high power amplifier, up down converter. Then you'll be having the baseband section. So the baseband section primarily the DSP components, the intermediate frequency section, demodulators, and director. Okay. So so this is the basic uh, diagram for any RF and baseband section. Obviously, this is a 2G phone. So probably this diagram will be available in Google Images if you just Google it on. So that is what I've given here. So okay. So the ultimate thing is that whether it is a one-dimensional signal like a sine wave, which you have to capture it in your antenna, then you have to. So dual band RF is nothing but a duplexer. Okay. So dual band RF. So you need to process the signal. If you want, you can go in for external storage, or in case if you want to give an audio signal, give an audio signal as input through this microphone, so you can do AD conversion. So all continuous time signals will be processed into digital signals, and so digital voice signal, so analog to digital converter, digital voice signal. So you can do some processing. So you can give in some binary ones and zeros through the keypad. So whatever might be the case, this is a simple arrangement. So to just let you know what are all the various RF and baseband components present in a wireless system. Okay. So now considering the fact, so as we all know, what is an analog signal and what is a digital signal. So an analog signal, as you know, this is an example for a one-dimensional signal. So because a signal is said to be a one-dimensional signal, this is a speech signal, arbitrary speech signal. So you have the time domain in the x-axis and the magnitude in the y-axis, amplitude in the y-axis. So this is an example for an analog signal, which I will not much go into detail, which we are all aware of. then what you need to do is you have to sample the signal. So you have to sample the signal. So sampling can be done by using sampling signals or sampling functions, sampling signals or sampling functions. So uh, what sort of work in this particular machine vision based wireless system startups will come into fact is that, so you need to develop some algorithms, you need to develop some programs to convert this analog signal into a digital signal. See, you might think that this is already an existing terminology, or this is already an existing concept. This Nyquist sampling theorem is an existing concept. So what sort of innovation or what sort of thing is that? See, innovation can be done either as a discovery or you can do it as a new novel product. So you can do some modifications by going in for inventing for some new sampling functions. So you can try to maintain the sampling rate and you can process further. So the objective of this particular wireless system based startups with machine vision is that, so this is a one-dimensional signal. Likewise, you can break up two-dimensional. You can process a two-dimensional signal, which is an image, which is given in the spatial domain, and you can do some processing, and you can provide some good outputs so that that can be marketed as an algorithm for any particular vendor. Okay, you need not have much funding for. With the low funding, you can work on these particular areas. That is what I would like to say. Yeah. So we'll see a small problem here. So it is given a wireless system. The data size is actually the voice actually here. So as we know, the bandwidth of the speech signal is nothing but it is around 300 to 3400 hertz, which we are all aware of. It is approximately 4 kilohertz. So the minimum sampling frequency, as you know, it is two times the message signal frequency, two times that are equal to two times message signal frequency, two times the bandwidth. So 8 bits per so the bits per sample is 8 bits. So it is 256 levels. So if you want to calculate the minimum data rate, so as we know, the data rate is an important metric for machine vision based wireless system startups where you can provide some proper solution. So minimum data rate required for transmission of voice. So voice is a one-dimensional signal. You need not require any special cameras or something like that. So this is just an what to say. This is a prerequisite for processing two-dimensional signals. Okay. So to calculate the minimum data rate, so the minimum sampling frequency into the number of bits per sample. So it is obviously around 8008 bits per second. So it is obviously 64 kilobits per second. So since it is a one-dimensional signal, the data rate will be very much less of the order of 64 kilobits per second. Okay. Then you have another application is that how to process the ECG signal, electrocardiogram signal. So the bandwidth considered here is 100 hertz. So the minimum sampling frequency is one nothing but it is two times 100, so it is 200 hertz. So bits per sample, so 8 bits per sample for representing 256 levels. So if you want to calculate the minimum data rate required for transmission of ECG in a wireless transceiver. So the minimum data rate is nothing but minimum sampling frequency into number of bits per sample. So the total data rate is also around 1.6 kilobits per second. Okay, this is for also an ECG signal. Now considering the fact, video signal, as you know, video signal. So if you capture, for example, if you capture a video signal, for example, if you take up this particular block diagram, so if you capture a video signal using your Android camera, or if you capture the video signal using your smart camera or whatever might be, it's a thermal imaging camera for any application. Okay, so this is where the what to say, this is where the concept of the video signal comes in here. Okay, so the video signal, as you know, video signal is a three-dimensional signal. So the number, so here I have considered for an example, the number of frames per second is 15 frames per second. So resolution of a frame is considered here to be 480 by 640 pixels. So these are it depends upon the user. So the bits per pixel is nothing but 24 bits for colored video. So now if you want to calculate the data rate, so data rate is a metric most probably associated with the what to say, the backend parameter. Okay, it's a backend parameter and it is not a front end parameter with respect to RF. So the minimum data rate required for transmitting a video in a receiver is similar to the previous one. similar to the previous one, similar to the similar to the previous one. So you can calculate the resolution of a frame, the number of frames per second, bits per pixel, and the data rate is nothing but 480 into 640 into 15 into 24 bits per second. So since it is video, the data rate will be much more higher, which it is shown here actually. So it is of the order of megabits per second. So this is how we can calculate data rate for a video signal. So these sort of information will be very vital for machine vision based wireless system startups, which I have given in here for information. So probably you can work on some research issues in the startup which you plan to, in case a particular entrepreneur wants to go in for a startup with wireless as the backend. So if you take a wireless transceiver, so it is a combination of a transmitter and receiver in a single package. So, wireless transceiver, either you can have the traditional 2G phones to up the 3G, 4G phones, or you can have the cordless telephone sets, or it is mobile two-way radio, just like a walkie-talkie. So you can either have simplex communication, or you can have half duplex, or you can have full duplex, whatever might be is. So you can work on any of these particular electronic gadgets, either in the physical layer or in the network layer, which I have given it later. And so you can contribute by writing programs in the sense either using assembly language program, or you can write in say a C program, or you can write in Matrix Laboratory or Slide Lab, whatever might be the software which is available as either open source software, or you can go in for a licensed version just like that of a MATLAB, and so on. So as I said earlier, wireless transceivers, it can be either as a half duplex or either as a full duplex. So half duplex, these are all some terminologies which you need to be aware of while writing some programs either in the assembly language or whatever which I have told earlier a few seconds before. And then full duplex. So these concepts you can know. I will not go much into detail into this. So whatever might be the application you can take, whether you can go in for a Wi-Fi based solution for any particular system model. So or you can go in for WiMAX, or you can go in for Bluetooth, or you can go in for Zigbee. So there are various possible applications or system models which you can consider, which are all said to be wireless. But the only thing is that the type of signal which you are going to give. So if you're going to give it a one-dimensional signal, it will not be considered as what to say, any machine vision based processing. If you give a two-dimensional signal, for example, a video signal taken for any particular application, a video signal given as input to a WiMAX system or a Wi-Fi system or a Bluetooth system, or whatever might be, or a Zigbee system, or whatever might be the case, or an ultra wideband system. So these are all some possible areas which you can work on in case if you go in for a particular startup, if you want to provide a solution. And all these are nothing but examples for startups with low seed fund. So even with some 300 to 400 rupees with the packet money, you can go in for a startup. You need not have much what to say you need not have much funding from angel investors or any venture fund. So only thing is you need to have a startup either by working from home, or you can approach some incubators or an incubation cell in any engineering institutions or any state or central government funded organizations. So, as you know, so the best particular wireless transceiver which you can work on nowadays you have the software defined radio and the cognitive radio. So, as you know, software defined radio is nothing but it is a radio which is of programmable type. Obviously, our mobile phone is nothing but an example for a software defined radio. A mobile phone is an example for a software defined radio. Probably you can say it as a cognitive radio, because you need to select the particular frequency, whichever frequency band is free. So for example, each and every cellular service provider, they'll be having their own uplink frequency and they'll be having their own downlink frequency for transmission of information for such for forward channel and reverse channel. So, and also nowadays many television white spaces are available. So you can work on cognitive radio based systems for, because as you know, the frequency spectrum is totally cramped. Frequency spectrum is totally cramped for various applications. So you can contribute at the backend sector by developing some programs, good programs, either in assembly language or in MATLAB or what, or in Simulink also, for software defined radio or cognitive radio. Or you can even also work in some digital processors. You have this home app, open multimedia application platform, home app processor. You have a sharp processor from, what to say, analog devices, or you can work from, but only thing is, even if it is processor based, some investment would be there. You need to go in for the kit. You have to process the signal, you have to dump it into the kit hardware sector, and you have to provide solution. So either you can go in either fully entirely as a software based, or you can go in as a hardware based. Okay. So this is the functional model of a software. This is the functional model of a software radio. So this, as you know, a software radio, as you know, you have the front end section and the back end section. This is the structure of a radio node. So you have source coding, you have service and network support, you have information security. So then you have bit by bit processing. So this is entirely analog to digital to analog conversion using your modem. Then you have IF processing. Then you have RF bar channel access. RF bar channel access. So then you have, in addition to that, multiple software personalities. So multiple software personalities is nothing but, so you will be having various radio nodes. So various radio nodes, and all these radio nodes will be running using the same software. So that is why it is called as software personalities. Then you have the post processor, and you have evaluation support. As you know, source coding is nothing but it is mainly used to remove redundancy. Source coding is mainly used to remove redundancy. That is nothing but the best known examples are Huffman coding, Shannon Fano coding, Lempelsive coding. These are examples for source coding. So where information bits which are not of what to say much interest will be removed. Okay. So what? So suppose if you are from an electronics and communication engineering background, or if you are from a CSE or IT background, so we might have studied about this information theory subject. So you can work on writing some programs for Huffman coding and Shannon coding. So even though you might think that it is already traditionally available, so you can contribute some modifications. You can try to improve the redundancy further. Okay. Anyway, the redundancy cannot be above 100 percentage. So you can try to maximize the redundancy nearing to 100 percentage for any system model. Which here this is given for a software defined radio. You can also consider for various wireless applications like Wi-Fi, WiMAX, or so on. Then you have the service and network support. Okay. So then you have information security and all these. So probably I'll go to the next slide. And okay. So the, as I said earlier, source coding and decoding. So either one-dimensional signal, two-dimensional signal, or three-dimensional signal with video, decimal, automatic, Xerox, and so on. Then service and network support is intended for multiplexing, setup and control, data services, internet working. That is all layer to layer. For example, network layer to network layer communication or cross-layer communication optimization will be governed by service and network support. Then you have information security. So application and for starting from the application layer onwards, all these security will come here. Then you have channel coding. So as you know, channel coding is nothing but introducing controlled redundancy. So introducing controlled redundancy to remove mainly or to minimize ISI, to minimize intersymbol interference. So to minimize intersymbol interference. Okay. So to minimize interference, you can go in for channel coding techniques. So baseband refers to the message signal. Modem is a analog to digital converter. You have synchronization, timing require. So as you know, equalization is nothing but removing ISI. So all these attributes, these functionalities refer to, that is introducing control redundancy is nothing but indirectly equalization. Then you have further black data processing. So black data processing in the sense is nothing but it is recovering the original data in decoding. Then you have IF processing such as beamforming. So beamforming is nothing but directional transmission and reception. directional transmission reception. Then you have diversity combining. So diversity combining is nothing but combining all the signals in case if you're going to go in for multiple antennas at the transmitting end and receiving end, then characterization of all the IF channels. Then, as you know, so these are the areas which where it refers to the backend baseband level, and this RF section or development of antennas, RF conversion, up down conversion, they are all come under the uh, front end section. So my topic of presentation will be more or less with respect to low seed fund. That is, I have taken just the back end version. Okay. Then you have the channel sets, simultaneous multiband propagation, wireline interoperability. So interoperability is nothing but it is with respect to WiMAX. Then you have the multiple personalities, then evolution support, then joint control. So any doubts from the participant side till now? So can you get along with my flow of presentation? Can you get me along with my flow of presentation? What I'm trying to convey? So any doubts in the sense, probably you can just ask me. Whatever which I have done through my specialization and whatever with the knowledge I can just share with you. So any doubts, please feel free to ask me. Any doubts from the participant side? Okay. Thank you. I'll proceed further. Uh, Wireless transceivers classification. So you can classify wireless transceivers with respect to the supply voltage, so frequency range. So all these parameters, they are with respect to the RF front end, and uh, the back end is nothing but with respect to the parameters such as data rate, that is the what to say, the error transmission, sensitivity and packaging type. These are all hardware related terminologies. So probably if you're going to go in for a machine vision based wireless startups, you can approach any uh, chip based designing companies which are normally situated in Bangalore, or you can approach some chip based companies in Chennai such as Nokia or something like that. Okay, so that but they will be cost effective, as I have said earlier, that you need to have a low seed fund. So low seed fund probably can contribute in the areas of error rate, packet error rate. You can contribute in terms of data rate. Okay, and as you know, you can also work in RF section provided if you plan to optimize the output power. So as you know, dBm is nothing but decibels with respect to 1 milliwatt, and dB is decibels, and you also have decibels with respect to isotropic radiators. Okay, as I've said earlier in the previous slide, so dBm is nothing but with respect to 1 milliwatt. So this is dBm. So here you have a small calculation here. So the transmission power of a wireless signal is 100 watts. Calculate the transmit power in units of dBm. So the transmission power so if you want to calculate the transmission power for 100 watts in dBm, this is a very simple calculation. So all you have to do is you have to just divide that by 1 milliwatt, and you have to take the log scale. So it is 50 dBm. So it is actually 50 dBm decibels with respect to milliwatt. Then wireless transceivers with the basic block schematic, you have the RF section and the baseband section. So as you know, the RF section, you have one second. So RF section, you have the analog components, which I have told earlier at high level frequencies. So these are the analog components which I like to relate for your ease of understanding. So the RF section, you have the antenna, the low noise amplifier, high power amplifier, up down converters. So then you have the baseband section. The baseband section means there is a message signal. So if you take any intelligent device like a personal digital assistant, like a mobile device or any particular one, so you have the baseband section. So the baseband section comprises of digital components of a particular level. So that is all low frequency level. Okay, so of the order of kilohertz or megahertz ranges. Okay. Um, so one second. So one second, Max, please. So as you know, you have the RF section and baseband section. So this is with respect to wire diagram. So you have the antenna. So the antenna is always considered to be a front end. You have the low noise amplifier. So you have the so conversion of megahertz to kilohertz ranges, down converter, demodulator, up convert modulator. So the LNA and the down converter, so it will come under most probably the RF section. And after the mixer or the oscillator, so you'll be having the IF section. And all these areas and a portion of this modulator will come under the baseband section. So you can work on this baseband section in case if you want to go in for a, low seed fund or a low cost startup, low cost startup. And as you know, analog to digital converter, as I've told earlier, that is sampler, quantizer, and encoder. Then vice versa, contrary, opposite to this one is the digital to analog converter, where you'll be having what to say, you'll be having the interpolator and the reconstruction filter. Okay, so and the digital baseband processor. Okay. So just to give more supplement to whatever I've told earlier. So wireless transceiver, the transmitter, we have seen the block diagram components. You have the information source, analog signal, one-dimensional signal, the speech signal, then digital signal and three-dimensional signal, probably which I have not go much into detail. Then you have the ADC, analog to digital converter. You have the source coder. You have this- Ma'am, is my slide visible, ma'am? I think I lost connection.
Sir, visible, sir. Yes, sir.
Okay, thank you, ma'am. Thank you, ma'am. I had an interruption. Thank you, ma'am. Okay. So you have the, as I told earlier, source coder. It removes redundancy, ones and zeros. Then you have the channel coding, control redundancy to reduce the channel effects. Then you have baseband processing of modulation. Okay. So considering the components where which you can contribute in the startup by working on some software programs, either in MATLAB or in assembly language or in C language, whatever which the entrepreneur wants to market his own idea for a particular startup. So you can contribute in correlator. As you know, correlator is nothing but a multiplier and an integrator. Then you have a match filter. So a match filter is nothing but it is a filter whose impulse response is matched to that of the channel. Then you have the detector. So a envelope detector, coherent or non-coherent detector. So then you have the decision device and multiplexers. So most of these terminologies are with respect to associated with respect to electronics and communication engineering discipline. So probably those who are from electronics and communication discipline background, so you will be familiar with this. Okay. So this is to give more insight into how the signal is transmitted and received. Okay. So for this is a one-dimensional signal. So here you can have a one-dimensional signal like voice, or you can have a image signal captured through a camera from a machine vision system. So if even though if it is a two-dimensional signal, you can convert the two-dimensional signal which is in gray levels by doing mapping into binary ones and zeros. So that mapping can be done by using any modulation scheme. You can map the gray levels into either +1 or -1, 1 or 0, or whatever might be the modulation scheme which you plan to mapping QPSK, or whatever might be the mapping process which you plan to do, and you can transmit them and receive them. So you have the up converter and the down converter. So a portion of the up converter and down converter will be coming under the backend section, baseband section, or the remaining half will be coming under the RF section. Okay. Okay. So what are the modulation schemes which you can work on the startup in machine vision based wireless system concept is that so you can contribute or you can do some research works or you can do some ideas for market viability either in the modulation scheme or you can work in the system architectures. Okay, so the modulation schemes you can work on some writing some variant of the modulation scheme, or you can propose some new modulation schemes for any particular application, WiMAX or Wi-Fi or Zigbee or Bluetooth or ultra wideband systems or whatever might be. As nowadays we are going in for 5G based applications, and nowadays and even 6G is going to come. So you can so the most commonly used modulation scheme in 4G is nothing but you have this OFDM variants of OFDM in 5G. So all these concepts which you can contribute. So OFDM, OK, UWB, okay. So minimum shift keying, all these modulation schemes you can write some programs. You can try to analyze the metrics of error rate or packet error rate in the network layer domain. And regarding the system architectures, so system architectures in the sense, so this will be most commonly with respect to a hardware based setup. So in case if you want to go in, you have to work on this particular area, you have to approach some hardware companies, chip based companies who are working in VLSI domain, who are working in VLSI domain. So super heterodyne receiver, IF receiver. Super heterodyne receiver is the most commonly known receiver where you have the RF amplifier, mixer, and oscillator and so on. So you can also contribute in these architectures. But considering the fact I've given here, even though modulation scheme is system architectures, so system architectures, so this will be a system will be cost effective. So this will be a system will be cost effective. It will be fairly under low cost. So it doesn't require much seed fund. So with the low seed fund and low investment, you can work on modulation schemes. That is what I would like to stress actually. Okay. So this is the block diagram of on-off keying transmitter. So on-off keying is nothing but amplitude shift keying. You might think that even though this OOK is outdated, on-off keying is outdated. On-off keying is outdated. So it has got good significance, even though it is immune to noise. It has got good significance in ultra wideband systems, short range communication, wireless personal area network systems, and in wireless sensor network applications. You can develop this sort of a transceiver. Develop this sort of a transceiver in the sense you can contribute at the back end. That is where you'll be having the low seed fund. You can develop some demodulators. You can go in for some envelope detectors. But however, power amplifiers antenna will be cost effective because you need to have specific antennas for specific applications. So the concept of a low seed fund to a certain extent will not be applicable in the RF backend section. Okay. Then this is the FSK transceiver. So FSK transceiver, as you know, variant of FSK is used in GSM systems, and even nowadays it is being used in certain what to say CPFSK systems in 4G, continuous phase frequency shift keying systems. So you can contribute in developing some filters. So filters in the sense a shaping filter. So shaping filter in the sense it can be either uh, low pass, high pass, or band pass variant. And you might think that this filter can be realized. For instance, if you try to develop it as a low pass filter, if you try to develop it as a low pass filter, only thing is you need to have a resistor and a capacitor in shunt. That will be a first order low pass filter. But you can write that as a program using MATLAB software, or you can write it using in some ALP language. So developing a shaping filter or a phase lock loop in a software section using a software will be itself a good idea, where you can pattern that idea and you can get trademark or copyrights for that, depending upon the approach which the entrepreneur in a particular startup decides to make money and make it commercially viable. So these are the areas whereby which you can contribute. As this area is nothing but it is what to say it is, and provide some good solutions. And these areas, power amplifier, low noise amplifier, these are areas where some sort of investment in terms from the startups entrepreneur side or from the incubator side, it goes on. So this is an example for a UWB transceiver. UWB transceiver, as you know, ultra wideband is nothing but it is short range communication. So communicating using short range pulses of time duration of the order of nanoseconds. Okay, so what to say, wireless personal area networks, WPAN, wireless personal area networks, they all operate under uh, using ultra wideband signals. So the reason for going in for ultra wideband signals is that they are more robust to interference, because short duration pulses, it cannot be easily what to say intercepted by noise or something like that. That is what I mean to say. Power levels of the order of what to say microwatts, or it even approaches nanowatts or picowatts. So that is what the low power consumption pulses. So to give advantages for this particular system architecture transceiver. Uh, Ma'am, am I connected, ma'am? Sorry to disturb. Ma'am, is my I think my signal. I have lost my signal. I think so.
Yes, sir, is connected, sir.
Ma'am, am I connected?
Yes,
Is
sir,
it,
no problem.
okay, thank you, ma'am. Thank you, ma'am. Sorry
Okay,
to
sir.
disturb, ma'am. Sorry.
Okay, sir.
Uh, okay. So, okay, ma'am. So this is the architecture which has been which we have seen earlier. Architecture which we have seen earlier. So architecture. So I've just given the advantages and disadvantages. So probably in the RF section, you can try to improve the sensitivity, selectivity, and in terms of power. But in terms of data rate, but in terms of data rate, it doesn't require much investment. In terms of components, you can develop some good algorithms for finding out the data rate duration of a human transceiver setup. So probably this you can easily go through. Probably it is a repeat of what just which we have seen earlier. Okay. It is stacking of more common transceivers. Okay. So whatever I've told earlier, whether it is a WiMAX or it is a Wi-Fi or it is a UWB based application. So whatever hardware section which you plan to develop, so it can be realized as a low seed fund or low cost startup using what to say some small programs, and they are all under low cost seed fund. So that is the objective of this particular AICTE. So from the participant side, till now, so probably I like to clarify before proceeding further. Okay. So any doubts from the participant side, which I'd like to clarify further. Okay, I'll continue further. Once again, continue further. Okay. So this is another low cost, commonly used 2.4 gigahertz. What to say? Bluetooth transceiver. So this is most commonly used Bluetooth transceiver, which is available in the traditionally available in the market. So probably you can try to work on some small IoT based projects or developing any particular application. Okay. Either it is a household application or whatever might be. So these are some of the ideas which I am just introducing to you, so that you can try to, in case if you go and plan to go in for a wireless based startup with machine vision, you can just contribute. So this is the chipset which has been given there. Okay. So proceeding further, so this is the with all these basic setups, with all these basic setups. So what we'll see how communication takes place in a machine vision wireless system concept. Considering the fact, what to say? Considering the fact, the computer networks, ISO's open system interface connection model. As you know, any wired or wireless application, they are governed by ISO's open layer ISO's open layer systems interconnection model, where you'll be having these 7 layers. So if you want to communicate from any one mobile to another mobile, so if you want to communicate from one mobile to another mobile, so just as it is given here, if you want to communicate from this particular mobile to this particular base station, so or it is a hardware CPU. Okay. So you need to classify the transmitting and receiving medium into the 7 layers. So physical, data link, network, transport, session, application, presentation layers. So obviously the other layers are not given up here. So probably so you need to know these concept. So if you want to communicate any data between any two intelligent devices, like PC to PC communication, or what to say, a laptop to laptop communication, or mobile to mobile communication, with the interference of a particular server or an exchange, whatever application which we are going to consider. So the physical layer, as you know, the physical layer is nothing but the layer which is concerned with the transmission of raw data bits. Physical layer is nothing but it is the layer concerned with the transmission of raw data bits, which is concerned with the transmission of raw data bits, whereby data bits are converted into raw signal is converted into data bits into binary ones and zeros for further processing as frames in the data link layer. Then you have the network layer. Network layer, as you know, it is concerned with the routing of data packets, routing algorithms, routing protocols, and all these. And also, you can have cross layer communication. Then you have the transport layer and application layer. So you can all contribute at the backend side, starting from the physical layer, data link layer, or the network layer. But even though the network layer, it involves the concept of routers or something like that. So you can go in for a software based simulation at the NS2, at the backend side. Okay. Okay. So once again, please. Once again. So the research issues. So the research issues concerned with the wireless systems. The research issues concerned with the wireless systems, as we have seen in the previous models. So you have the physical layer analysis and you have the network layer analysis. You have the physical layer analysis and you have the physical layer analysis and the network layer analysis. So the for the physical layer, you have the what to say, the performance metrics are bit error rate, capacity, spectral efficiency, outage capacity. Okay, and from the network layer perspective, you have the routing protocols, routing algorithms, okay? And the performance metrics, as we know, you have the throughput, latency, packet error rate, and delay. So these are, if you work on physical layer and the network layer to a certain extent with the uh, software, so you can what to say, you can what to say the mm, uh, uh, some low cost based arrangements for a particular startup with wireless system as backend. Then at the emulation level, you have hardware based DSP processors. As I said earlier, while we were going on through the earlier slides, you have the analog devices, visual DSP plus Texas Instruments, Code Composer Studio. So these are something which is more costly, and the investment is somewhat high because you need to purchase all these visual DSP plus hardware processors and DSP kits. Probably you can get funding from the incubation cells or the business incubators in case if you are working like that. Okay, so as the objective of this particular Sttp is to work with low seed fund. So low seed fund in the sense you can concentrate on physical layer analysis where you can just develop some programs. It is where it is all with respect to the working capability or the efficiency of the entrepreneur or the group of entrepreneurs working in that particular startup. So as you know, wireless signal transmission, for example, you have this sinusoidal signal. So this is a one-dimensional signal you can transmit into the wireless channel. If you transmit into the wireless channel, you have this attenuation components of alpha, and you have this phase components of phi. Actually, attenuation components of alpha and the phase components of phi. Okay. So if you take the wireless system model, so from the probably this particular slide onwards, so the information which I try to convey to you will be helpful for going in for a startup by an entrepreneur with low seed fund actually. So these some terminologies which are these mathematical equations which will be very much helpful for you to write some programs at the physical layer level and analyze its metrics in terms of bit array. Okay, so y of t is equal to x of t. This is for the perfect channel case, and y of t is equal to x of t plus uh, n of t for this is for an AWGN channel with this is for an AWGN channel that is it is an additive white Gaussian noise channel where Gaussian in the sense it follows normal distribution. So normal distribution and white in the sense, so since this noise is present in all the frequency components starting from the low frequency range to the high frequency range, you have white. Then addition of all these components cumulatively will result in additive white noise. Okay. Then you have the real case of the flat fading channel, and then you have the frequency selective fading channel. So a wireless channel, depending upon the availability of the open air medium, wireless medium, it can be either a flat fading channel or a frequency selective fading channel, depending upon the signal frequency and what to say, the channel frequency. Okay, so okay, so here the case study which we have considered here is a cognitive radio. So we have already considered the fact of a software defined radio in the earlier slide, probably which I'll try to correlate. So this is the functional model of a software defined radio. So this software defined radio, so if you just go in for some sensing concept, if you just incorporate or add sensing concept with software defined radio, it becomes a cognitive defined radio. If we just add a software defined radio with a spectrum sensing concept, it becomes a cognitive radio actually. That's what I would like to add on further. Okay. So if you look into the case study of a cognitive radio, so you have the hardware setup and you have the software setup. So in the hardware setup, so most probably the RF section will be governed by antenna RF, and the modem you'll be having A to D and digital to analog converters. These are all software sections. So either you can realize this section entirely as a software in the baseband section. So information security, you can realize this even though it is written here hardware. You can realize this section in your startup, machine vision based wireless startup, by taking on any image signal and analyze this system. Then you can also process them in the software. So it is given as a hardware setup and a software setup, depending upon whatever might be the sector you want to contribute in your startup. You can just work on either in the hardware section or in the software section. Then cognition, as you know, is nothing but if you as I told earlier a few seconds back, so you can make a cognitive radio by just adding spectrum sensing concept with a software defined radio. That is what I mean by cognition. That is sensing whether this frequency band is available or not. Okay, so each and every cellular service provider, they have their own frequency band for transmission and reception, which they normally get by auction from the Indian government. Okay, so they have to bid for getting a particular frequency spectrum so that they can transmit and receive probably for a period of year, depending upon the MOU, which the timeline the Indian government says. Okay, so you can transmit and receive, you can contribute in the equalizer section, or you can develop some protocols. So developing some protocols, in the sense you can develop some protocols. Developing a protocol is not that much easier. You have to say a set of rules, either in you can develop in Java, or you can develop in what to say in C language, or whatever might be the case. And you can develop that protocol idea and market it uh, for proper commercial viability. But the first thing is that you need to get your idea patented, or you have to get proper copyright, so that you'll be having proper loyalty or royalty for your particular work which is being done. So then you can also contribute in various radio knowledge, radio language encryption frames. So model based reasoning. So the model based reasoning is nothing but working on some fuzzy based classifier, or clustering algorithm, or you can contribute in artificial neural networks, or whatever might be the case. Okay, so this is the cognitive radio case study where you can contribute in your wireless system based startup. Okay, so so whatever might be the case, whether it is a hardware or software, and if you are working in the backend side, baseband side, um, you need to know the system model. The received signal R of t is given as R of t is nothing but alpha of t e power minus j theta t s of t plus n of t. So alpha of t is the gain of the channel, theta of t is the phase shift of the channel, n of t is in the additive Gaussian noise. So alpha and theta are the terminologies which is based on the wireless channel impulse response. So you can analyze the metric. So you can evaluate the probability of error. Either you can contribute in terms of mathematical statistics for any particular digital modulation scheme in a slow flat fading channel. Then you can market that particular mathematical statistics as any algorithm by writing it in either C language, or you can write in MATLAB software script, and you can just have that as an algorithm for proper patenting or so on. Okay. So this is the CR system model. So for to work in the backend section or in the baseband section for any wireless system based startup, so and especially with respect to low seed fund, the CR system model needs to be considered. So x of t is nothing but n of t is considered to be noise, or it is null hypothesis, and this is nothing but h into s of t plus n of t, where h is the wireless channel and s of t is the transmitted signal. Then n of t is the Gaussian noise. So n of t is the Gaussian noise, and h1 is nothing but it is the active hypothesis. So if the cognitive radio system, if it senses the availability of a frequency spectrum, then it is considered to transmit and receive in this particular hypothesis, or otherwise it is considered to be there is no availability of frequency spectrum in the null hypothesis section. That is probability of false alarm or probability of detection. So why I'm saying is that, so these sort of performance measures or the deciding factors need to be considered while writing a program, in case if you are going to analyze the performance metric for a cognitive radio. Okay, so here I've given a performance metric to analyze the uh, capacity of a cognitive radio system. I'll help you out how to determine the capacity of a wireless system. Here, the considered case is cognitive radio system. Mm, Cognitive radio system. So here the received signal model. So here, for any particular setup, you need to consider the received signal model R of t. You need to consider the received signal model R of t. That is very important. So this is so here I've given it here. So the case for a flat fading channel. So here R of t is the received signal. Y of t is nothing but R of t. Alpha of t is the magnitude. Instead of x of t, you can have s of t or whatever it is. So this alpha of t into e power j theta of t is the channel h, and this x of t is nothing but this is s of t. So y of t is nothing but it is the received signal. So this is the so this is I'm just trying to correlate x of t with y of t as per the previous slide. Okay. So here R suffix COG. So since it is a cognitive radio system, so after spectrum sensing, we're finding out whether the channel is free. H is the channel, and D is nothing but it is the S of T or the transmitted data, and N suffix COG is nothing but the it is the Gaussian noise. N is nothing but it is the Gaussian noise. N is nothing but it is the N is nothing but it is the Gaussian noise. H suffix COG is a scalar wireless channel which is experiencing flat fading or undergoing Rayleigh distribution. So since it is a flat fading channel, so it will take the representation of alpha of t e power minus j theta of t into s of t. And n of t is nothing but it is the AWG noise or the noise present in the PCB of your mobile. Okay. So N suffix COG is the PCB noise. For I'm just saying it as an example, the noise present in the PCB of your mobile. So primary receiver. So these are some mathematical statistics where you have the complex Gaussian noise vector. N is nothing but mean mu and variance sigma square. So likewise, if it is a frequent selective fading channel, so frequent selective fading channel, that is the signal bandwidth is greater than the channel bandwidth. R suffix COG of N is nothing but it is the fading channel, H suffix COG, and D of N is nothing but it is the data, and N suffix COG is nothing but it is the Gaussian noise. So to find the capacity of a particular cognitive radio system, so it is nothing but maximization with respect to mutual information. It is maximization with respect to so it is maximization with respect to mutual information, and D is nothing but what to say, D is nothing but it is the transmitted data. R suffix COG is nothing but it is the received signal. So this is a simple derivation, and these sort of derivations are normally written as programs either in assembly language program or in MATLAB, and it is stored into any intelligent device, just like mobile. So a mobile can be a cognitive radio, can be for example for a cognitive radio because it senses the vacant spectrum and it provides connection from one mobile to another mobile. So so I'm just trying to correlate whatever you can work on a startup with low cost at the from wireless perspective. Okay, so your signal can be either one-dimensional signal like a speech signal, or even you can transmit an image. For example, if you are transmitting a JPG file, there is nothing but an image file. So a JPG image file in your mobile, either in your WhatsApp or if you're transmitting via through Bluetooth, they'll be converted into binary ones and zeros. They'll be converted into binary ones and zeros depending upon the mapping which you're going to use at the baseband side. That is the modulation scheme. So that is one thing which I'd like to stress. Okay. Now, as I've told earlier, capacity is nothing but it is maximization of mutual information. capacity is nothing but maximization of mutual information with respect to the transmitting data and the receiving data. So, R suffix COG is the receiving data, and D is nothing but it is the transmitting data. R suffix COG is nothing but the transmitting data, and D is nothing but it is the D is nothing but the transmitting data, and R suffix COG is nothing but the receiving data. So the standard formula. So this sort of derivation you can look into the standard textbooks given by what to say a standard textbook. A standard textbook given by Digital Communications by Simon Heikin, or Communication Systems or Digital Communications by Prof. So these are some standard textbooks which you can follow for doing these sort of derivations. So probably these derivations are probably abstracted from Digital Communications by Procase, from Wiley Communications, and it has been extended for cognitive radio applications. So likewise, you can extend this application for what to say WiMAX, or you can extend this for Wi-Fi or any particular application. Okay, so that is what. So R suffix COG is nothing but the received signal data, and if you take the entropy, that is the differential entropy of this particular signal, R suffix GOG, and conditional entropy. So if you take the transmitted data D, and if you take the received data D, it is called as noise entropy or the differential entropy. So this is the basic formula to calculate mutual information, and if you maximize the mutual information, so you'll be getting what is the capacity. So wherever we go, capacity of a wireless channel is very significant, whatever might be the application, and the channel differs from environment to environment. Okay, so the formula for differential entropy is nothing but, so this is H suffix RCOG is nothing but 1 by 2 log base to 2 pi sigma 2 pi E. So 2 pi is nothing but it is the entropy which is being considered, which is measured in nats. So this is, and sigma square R suffix COG is nothing but the variance of the received signal vector. So this is expectation of variance of the received signal vector is nothing but expectation of the received signal and it is complex conjugate. Hermitian refers to complex conjugate. So sigma square R suffix COG is nothing but, so we are just substituting this value of R suffix COG, which is in equation 1 probably. So the value in equation 1, it is being substituted here, R into R suffix COG. And if we simplify this further, so it is just cross multiplication. It is just cross. I have just brought in this Hermitian term here. I have done some. So AB whole Hermitian is nothing but P Hermitian, A Hermitian, like that I have given it here, and then cross multiplying these terms, so we get these 4 terms. Okay. So if you look into these terms, so this is expectation is nothing but statistical average. So this is what to say. So this is channel and this is data. So this is channel, data, and noise. So cross correlation. So noise is always considered to be random here. Noise is considered always to be random here, and D is nothing but deterministic. So cross correlation of a deterministic signal and what to say, correlation of a deterministic signal and a random signal is considered to be 0. So it is independent. So these terms will normally vanish. Okay. So the second term and third term will normally vanish, which I have given it in the later slide. And you have only this correlation terms. Okay. So I've given here where the second and third terms are 0 as cross correlation is independent, hence it is 0. Okay. Second and third terms are independent and cross correlation is considered to be 0. Hence only the first and fourth terms are significant. That is what it is given here. So D is the data, H suffix COG is nothing but the channel, which is either flat fading or it is a frequent selective fading channel. Then R suffix capital R. So capital R is nothing but it is a noise correlation. Capital R is nothing but noise correlation matrix, which is random. And so we are rewriting this H suffix RCOG. The fifth expression becomes what to say, this 10th expression. And also you need to find out what is the conditional entropy. So the conditional entropy is entirely noise entropy. So only you'll be having only the noise terms, the noise terms to occur over here. So this expectation, this fourth term, expectation of n Hermitian cognitive, is nothing but it is the noise correlation. Well, that is what it is written here. So further, the mutual information is written by substituting 10. So we have found out what is 10 and 11. So 10 and 11 is nothing but, so which is used in 4. So this is the H suffix RCOG and H suffix RCOG by D. Okay. So 10 and 11 and 4. So this is 4 over here. So this is a very simple derivation. Only thing is you need to know some statistics, proper statistics you can contribute. So the mutual information is written like this here. Then by using this log A by B representation, log A minus log B. So log A plus log B. So we've just written it here. Then we just simplified. So this these two matrices will get cancelled out here, and this will become as an identity matrix. Once when you want to take the determinant, it becomes an identity matrix. So this is mutual information on simplification of 14. So this is a mutual information on simplification of 14. So mutual information on simplification of 14 actually here. And as we have seen earlier, capacity. As we have seen earlier, capacity is nothing but maximization of mutual information. So we have found out what is I of D dependent on R suffix COG, and we have to just substitute this into 3. So we have to just substitute this into 3 actually here. So that is what it is given here. So substitution of 15 in 3. So substitution of 15 in 3, which is given here. Substitution of 15 in 3. So we can find out what is the the capacity of a cognitive radio system. The capacity of a cognitive radio system is found to be somewhat a mathematical expression like this. So now what you have to do is, you have to write a small programming segment either in C language or in MATLAB, either in licensed version, or if you have whatever if other possible, if you want to write an assembly language program. So whatever you can do, you can write a program for a particular metric. Here it is given for a cognitive radio system. You can write that in your particular wireless system based startup. If you want to transmit either a video signal or a two-dimensional image signal, and that will be a possible research problem which can cater to academic sector or the industrial sector for any particular product development. So this only requires whatever we have studied as a student or a faculty or a researcher in the course of study for a particular CS engineer or a IT engineer or a EC engineer. You can write programs and you can just find out the metric here. So this is, for example, the graph which is given here. So this is the plot of graph either in this is done actually in MATLAB actually. So in the x-axis you have the signal to noise ratio. As you know that signal to noise ratio is a dimensionless number. So here for analysis it is given as it is given in decibels. It is given in decibels. Then you have the parameter capacity of a cognitive radio system given in capacity. So here this is a single input single output system where it is considered for the case of as a single antenna at the transmitter and the receiving end. So it is done in MATLAB programming environment, and for a flat fading case and for a frequent selective fading case. So these are some simple programming segments which you can write and develop in your startup, machine vision based startups, and you can just market it for any particular vendor or any particular organization or any corporate sector and so on. So this is the example. So any doubts for the participants up to now here? So I've explained one performance metric. So any doubts for the participants till this particular segment? So this is a performance metric which I have given here. So if there are no doubts, I'll proceed further.
Prem, a question is posted in the Prem. A question
Yes,
is
sir.
posted in the chat box.
Yes, sir. Yes, sir. I'll just look at it. One second, sir. Um, one second. Mm, 1 second, probably I'll look it up. Okay. So, so it's a question from Dr. Shankar. How does the carrier sensing helps the transceiver when images or videos are transmitted as the data rate is high? So this is actually a different one. So, sir, actually, so if you take so carrier sensing in the fact with respect to you have to sense whether the channel is vacantly available or not, whether the channel is available or not. So carrier sensing is in no way related to data rate. So data rate is nothing but signal transmission. So signal transmission can be either an image or it can be a one-dimensional signal. So carrier sensing is nothing but spectrum sensing actually. Carrier
Oh,
sensing is nothing but spectrum sensing. We have to detect only whether the frequency band is available or not. We have to go in for probability of false alarm and probability of detection actually.
so but
So
data depends on how much data we can send through depends on that, correct?
yes, sir. Yes, sir. It depends upon the amount of data. So if you go in for parallel processing with OFDM, the data rate will be much more
Much more higher. Okay.
much more higher. So there is no trade-off between carrier sensing as the question which is being asked with respect to cognitive radio setup or any particular application, Wi-Fi or WiMAX, but data rate is entirely a different factor.
Okay.
It is not at all an issue, sir, because it is either an image or either a video. Video needs to be truncated into frames. Just I have
Small Yeah.
segment as a frame grabber, sir, actually. So it is not an issue, sir, actually.
Okay, fine.
Okay, sir. Thank you, sir. Thank you very much, sir.
Thank you. Thank you.
Mm, Once again, sir, I'll proceed further. It's my once again, sir. Okay. So this is a small programming. This is a small programming segment. So how to calculate the capacity of a channel? So this is actually more or less information theoretic approach actually. So information theoretic approach. So we can have any. So this problem is available in any standard textbooks actually. So you can calculate what is the capacity. So this is in accordance with Shannon-Hartley theorem. So you can calculate so whatever. So these sort of small programming segments will be helpful while we are working on in any real-time application. In the sense, you have to capture the video or you have to capture the data and then do further process. So you can calculate the amount of capacity what a wireless channel for a particular application the upper limit is. So you can, so in this case which is considered here as per this problem which is available in standard textbooks, the capacity is found out to be 10 megabits per second. So likewise you can judge easily. Okay, so the important thing in what to say in the wireless system based startups is that we need to have proper validation, because validation has to be done only through mathematical statistics, mathematical derivations. So you have to derive mathematically, just as I have told through the derivation. So what is all the what to say the result which we get through the mathematical graph, and what which we get through the values which is being obtained, because it is highly difficult to measure the wireless channel through without any proper arrangement or memorandum of understanding with any industry or something like that, because you need to go in for RF channel sounding. That is a somewhat you need to approach some specific organizations which they would have got permission to access the wireless open medium air. That is one thing which I intend to convey. So this is the capacity of a channel actually. Okay. Then, as you know, these are some statistics which I have given for binary phase shift keying. Even though you might think that this binary phase shift keying is outdated, so still its variants are used in nowadays as CPFSK modulation scheme, continuous phase shift keying modulation scheme in 4G technology. Okay, so 4G technology, it uses CPFSK and most prominently OFDM modulation scheme. That's what I would like to stress on. Okay, so why I've given is there. You need to know what is the transmitted signal. What is this transmitted signal model? So if it is BPSK means +1 and -1. You have to decide on what is the basis function. Okay, and what is the signal constellation. I will not go much into detail into this particular thing, which will be, because most of the engineers from CSE, IT or communications background will be aware of. Okay, so the fact is that you need to decide out what type of channel you're going to work in your particular startup in the wireless domain, whether it is a frequency fading channel, frequency flat fading channel, or wireless channel. And you can also incorporate what to say that. So see here, there is another fact is that depending upon the Doppler spread, so you can have a channel to be a slow fading channel or a fast fading channel. So if Doppler comes into picture, if there is a relative movement between the transmitter and the receiver, so for instance, if we are talking to a particular person while we are slowly walking, or if we are traveling by a two-wheeler or a car, and if we are conversing, then Doppler ultimately will come into picture. Then the signal statistics will vary. So but whatever might be the channel case which is not in our hand, so we can contribute on the algorithm part of view. So we can try to go in for hybrid. Nowadays hybrid is coming in all fields of engineering, not only in the agriculture sector or whatever might be the case. So we can go in for some hybrid modulation schemes. So probably to be frankly speaking, so we can develop some hybrid modulation schemes, and we can even have our individual names, and we can say that this is a new modulation scheme which we have developed, something like that. That can be contribute to something like a discovery. But the fact is we need to have proper validation. So proper validation in the baseband section can be done only through mathematical derivations or statistics. That is one thing. But that will be contribute to a low seed fund based startup. That is what I would like to stress. Okay. So so the performance in fading channels. So alternately, the probability of error. So if you want to calculate the probability of error as a conditional error probability, where the condition is that the one probability will be fixed. So this is the P of X is nothing but it is the arbitrary probability of error, which I've given it in the next slide. Then P of X is nothing but the probability density function. So we need to know some mathematical statistics, random process, okay, for working on this, but that is not quite that much cumbersome, difficult. So we can work on. So P of X is nothing but the probability of error for an arbitrary modulation scheme, which I've told earlier. So this is the P of X, which I told earlier, P of X. So this is for an arbitrary modulation scheme, and X is nothing but alpha square EB by N naught, and EB by N naught is nothing but it is the bit energy by noise energy, which is signal to noise ratio. And P of X is small P of X, nothing but the probability density function, and alpha square represents the instantaneous power values. So all this we can write as programs for various fading channels. So this is for information of a relay fading channel or a non-line of sight channel, which we have given. So P of X is nothing but 1 by sigma exponential of minus X by gamma. So this is instantaneous power, average power. So this is for extra information, and these are some standard formulas which we can find in textbook of digital communication by Prokes, digital communication by Prokes. So we can work on this particular. So even though, as I have told earlier, these are all not some outdated modulation schemes. These are some digital modulation schemes which are front runners for various hybrid modulation schemes which are coming out in various research papers, which can provide some good improvements or enhancement in terms of bit error rate or capacity or whatever might be the approach which we are going to consider. So the important thing is that you need to know what are all the theoretical formulas. So here I've given it for phase, frequency, and amplitude shift keying. So ERFC is nothing but the complementary error function. So I will not go much into detail. So probably you can just work on, if any entrepreneur or any student or faculty member or researcher wants to start a particular startup. So these terminologies you need to be aware of, and this is the important metric. So for baseband section or the backend section. So wherever, if you want to work in the backend section, the baseband section, which is the requirement for a low seed fund, probably for this particular topic of Sttp. So you need to find out the probability of error or the bit error rate. So as I said earlier, validation is very important. So validation, you have to do it not only by implementation, by using a hardware setup. So validation can be done through, what to say, through software programs and practical Monte Carlo based operations. As you know, Monte Carlo is a place in US which is famous for casinos, which where games of chance are being played. Okay, so based on that, you can do trial and error approach using this practical and what to say, you have this theoretical approach. Okay, so validation in terms of theoretical formulas, just as it is given here. So you need to go in for develop some formulas through various derivations, and if you can practically validate that by using what to say, these are trial and error programs. So these are all low cost, very less. Only thing is, it will require the knowledge of the programmer. It will require the knowledge of the programmer to work on particular concepts like this. So this is given for an AWGN channel. Likewise, you can work for a flat fading channel or something like that. Then this is the bit error rate. This is the bit error rate in multipath fading channels. So so you have AWGN channel, flat fading channel, and a frequent selective fading channel. Sorry. Frequent selective fading channel and a flat fading channel. So if you want to analyze the performance metric of any particular modulation scheme, so you have to fix the probability of error. See, for instance, if you take 10 power minus 2 probability of error, so if you traverse along this, AWGN is not at all a physical channel. As I've told earlier, that you're doing some processing in the mobile itself. Your mobile is an example for an intelligent device like a cognitive radio. So it takes only around 7 dBs. So this is not at all a physical channel. So there is no wastage of power, very less power. Okay. And if you traverse further, if you take a flat fading channel, if you take a flat fading channel, this blue line, it takes around 14 dBs. That is what we can presume from this approximately. And if you take this red line, it reaches around 13 dB. So there is what to say, 1 dB improvement between this red line and the blue line in terms of power decibels. So if this red line takes 13 dB, if this blue line takes 14 dB, there will be a 1 dB improvement in power. So what we have to do is, we can't say which channel is better. We need to reduce the power level. So if you try to reduce the power level, then the battery power can be retained for a much more long time, or power control will be there. So, or what to say, so power consumption can be minimized. That is what it ultimately implies. So researchers can contribute in wireless system based startups. Researchers can contribute in wireless system based startups by working on these particular domains. Okay. So probably, so what I will try to do is, I'll try to explain a programming segment so that it will be helpful for you. I'll stop my screen and share a programming segment, which is a small programming segment which I have. So one second, please. Please stay connected. I'll try to uh, share the programming segment. I think programming segment once again. I don't know where I have kept it. 1 second, I have to programming segment. Once again, 1 second, I have just as of now I don't have that. Okay, I'll proceed further with this one. I don't have that. I don't have that immediately. Probably I'll share with the programming segment later. I'll try to proceed with the programming segment. Okay. Okay. I'll try to share with you later. Uh, so proceeding further, so as the wireless system reaches for 5G technologies, so wireless system reaches 5G technologies, so you can contribute on what to say in the baseband section in terms of data rate, you contribute in terms of data rate, some multiplexing terminologies. So these are all some low cost. Or if you work in the network layer perspective, you can contribute in terms of packet rate. So the other concepts, polarization, handoff, all these will be coming under the RF section. Okay, so probably you can work on this and you can try to go in for a low cost based startups. Yeah. So, as finally to conclude further, so market validation. So market validation is very important. So I've told earlier that market validation, you need to have proper validation through low cost arrangement, either through theoretical formulas and through practical formulas for any modulation scheme, which I have stressed earlier. So you can decide out a particular problem such as probability of error. You can have capacity as a metric. Find a solution. Solution is nothing but for here we have introduced capacity for of a cognitive radio system as a solution, and the fact is that you can, if possible, you can build a viable product or you can develop an algorithm and validate the business models. And the other advantage is that there are tax exemptions for startups. Tax exemptions are startup. You can log into startupindia.gov.in and you can see all those startups. Then the startup process can take a long period of time. So in sustaining, as I said earlier, sustaining it depends upon the entrepreneur. So if the entrepreneur approaches any incubation cell or any incubate business incubator in any organization, so that sustainment is very high. Probability of sustainment of that particular startup by an entrepreneur is very high. So, but then the drawbacks is that sustaining effort is especially uh, if, there are chances of getting failed because the fact that investment. So you need to have angel investment. It depends upon the approach which you are going to take on. Okay, and finally, before concluding, so as I said earlier in my objective slides, the startup schemes in state government and central government sectors. So you have Atal Innovation Mission via Atal Incubation Centers. You have public-private sector established incubation centers. So you can log into this particular site, startupindia.gov.in. So there are various opportunities through MSME also. Once when you get your idea patented in any patented, and if you approach any what to say MSME where you can get a corporate identification number, direct identification number, and you can make your what to say your startup to get sustained with good possibility. And as I said earlier, women entrepreneurs are encouraged by the Indian government. They are given rupees 20,000 per month for initial period of 1 year, provided they should be the founder or co-founder. Then you have this national innovation and startup policy. So starting a startup with the low seed fund with the low cost is not that much difficult. It depends upon the motivation and the factors which the or the approach which the entrepreneur which who plans to start a particular startup. Okay, so probably I'll end my presentation here. So if you have any doubts you can please can ask me for your
Any other doubts? Post your questions in chat box.
so any other doubts, probably I'd like to clarify with whatever experience which I do have.
Sir?
Ma'am, tell me, ma'am.
No queries.
Okay, ma'am. Okay, ma'am.
I conclude this, sir.
Okay, ma'am.
Lot of thanks, sir. I would like to extend a special thanks to Dr. M. Premkumar, sir, for giving us a wide knowledge about mission vision for wireless system startup and for inspiring us. Thank you, sir. And also, I thank all the your time. Thank you. Thank you all. So,
Thank you, ma'am.
participant, the feedback link is posted in the chat box. Please do fill it before you can leave the meeting. Thank you, sir.